Isaac, can you hear me?
Yep, I think we're good to go. I think we're live and ready. I think we're going to give it about a minute for folks to kind of filter in, and then we can go ahead and kick it off.
Perfect.
As we wait to have everyone start coming in, I just want a friendly reminder that there is a Q&A component on the right where you can ask questions. We're going to have some folks on the Tecton side and AWS side able to answer those questions during it, and we're also going to save some time at the end to answer some additional questions. Great. Well, it looks like we're 1 minute after, so we can go ahead and kick off the presentation. I'm Isaac Cameron. I'm a resident solution architect here at Tecton. I'm joined by Arnab, who can do a quick introduction as well.
Yeah, hi everybody. Isaac, thank you for having me here. Really appreciate it. My name is Arnab Sinha. I'm a solutions architect at AWS supporting Gen AI ISV customers. And I am here to talk about our partnership and integration with our core offerings. Yep.
Great, thank you. So pulling up the window, we're able to let's talk through what we're going to be discussing today. So today, we're going to look at how Tecton and Sagemaker are able to accelerate the development of AI and ML applications. We're going to be focusing on how Tecton and Sagemaker are able to address two major bottlenecks. The first bottleneck is going to be around the lifecycle development of features and ML applications. A common workflow that you see in the current state is that, say you're building out a fraud detection engine, and you might start with a hypothesis about a new fraud signal. Say, hey, we can catch more fraud by looking at failed login attempts over the last week. You can test this in your notebook, kind of maybe building out some pandas code, and maybe you see some promising results. You might then take that code, pass it over to your data engineering or ML platform team partners. They might work a couple iteration cycles to productionalize that, make sure that that code is performant, reliable, and cost efficient. And then they might go through their additional development cycles in order to get that fully into production and useful by your ML models. This takes a lot of time in order to get that value. And when you're working with fraud detection, where you have adverse agents, that time can be millions of dollars in value. So overall, we're going to talk through how we can go from months to days or even hours for that feature development and ML development lifecycle. The other major bottleneck we're going to discuss is around the infrastructure. It takes a ton of engineering work to build, manage, and high-performing infrastructure for real-time ML use cases like fraud detection. ML teams usually end up with a maze of brittle architectural components with months-long deployment cycles to add even one feature or one new ML model. It might seem straightforward for like some batch data, but it gets way more complex as you start adding stream data sources, real-time data sources, or advanced topics like model-generated features, embeddings, encodings, etc. Anecdotally, I know this from experience in previous life, built out a very similar architecture to here, and it takes a ton of time and effort in order to build both the application layer as well as the foundational layer needed to handle your organization's requirements, whether that's around resilience, governance, observability, and monitoring. From my own experience, once you've completed these things, you end up spending more time maintaining your existing infrastructure or your existing use cases instead of actually building out new systems. So this is where Tecton and managed services like Sagemaker come into place. Tecton is a data platform for your AI applications. it extracts away of the complexity of building production-grade data pipelines for AI and ML use cases, ensuring quality, performance, and resilient applications. Tecton can handle your end-to-end data needs, including the data processing side, the storage side, as well as that feature serving. And it also is able to extract away that foundational level around disaster recovery, governance, lineage, and other observability requirements. There's three major things I want to kind of highlight within the Tecton architecture. As looks like I'm off on the slide here. The first is around the empowering data scientists to easily build production-grade code. Tecton has a declarative framework that abstracts away the complexity of building these feature pipelines, allowing your data scientists, data analysts, business analysts to build these production-grade features and avoid that bottleneck around ML and platform engineering teams needing to deploy this code. The other area is around time to value. Tecton is able to accelerate that time to value by enabling your ML engineers to iterate faster. And the last thing is around scalability, latency, and model performance. Tecton is able to handle high traffic use cases, 100K RPS, as well as very low latencies, 10, 20 millisecond for your end-to-end feature pipelines. So with that, I'll hand it over to Arnab to talk through Sagemaker and how it addresses some of these bottlenecks as well.
Thank you, Isaac. So wanted to give you guys a quick intro to Sagemaker for those that haven't really interacted or played with it. So Sagemaker is a service that was announced back in 2017 at reInvent. And it really started out as a platform, as you can see on the slide, focused on data scientists and researchers and ML engineers and data engineers that were the critical people that were required to build machine learning models. And we wanted to take away that undifferentiated stuff that Isaac kind of referenced in the prior slides and make it easy for them to build models and deploy them and really focus on the model architecture and the business logic that kind of fuels their use cases. So, Sagemaker started out supporting the typical Python R frameworks. And then we saw that as AI matured, Amazon Web Services together has a history of 20 plus years of building models within their ecosystem. We found that we wanted to enable other different personas. And that's when in 2021, we launched Sagemaker Canvas, which is our low-code, no-code platform that allowed business analysts and product managers to be able to stitch together using data, a model that they could get some initial feedback. The other aspect we realized later in the more recent years was that people started getting curious, and with this influx of generative AI and curiosity across all different verticals of how to leverage AI, we decided to really open up Sagemaker Studio Lab, which is all you need is an email address to sign up and start playing around and learning. So I don't know if you guys have seen this, but AWS has committed to $50 million over the next 2 or 3 years to empower startups, universities, labs to leverage our tools to learn about AI and how AI can fuel their use cases. And the last thing I wanted to talk about this slide is, if you can, I know it's kind of busy in the bottom. There is this Sagemaker Studio IDE, which is what I call the most collaborative and friendly interface for you to build all the different aspects of model development and model inference within your environment. This is kind of touching upon MLOps, and we will kind of talk about that later in the presentation, but wanted to touch upon that. And for today, if you can go to the next slide, Isaac, what we'll focus on today is, Sagemaker is just not one or two things. It's got within itself like crazy 200 plus features. And I'm not going to be, boring you with all the different features. So for today, what I think is most relevant is in the space of data preparation, model build, train and tune, and then deploy. And what we are doing here is really helping with the infrastructure. You can start out with a Jupyter Lab notebook server, which it doesn't have to be the beefiest of machine, but then delegate when you're ready to run that training job in the biggest NVIDIA GPU machines, if you choose to do that, if that's what your use case needs. We allow automatic model experiment tracking and metrics so that you can keep it be iterative and start tuning your models or tuning your experiments to get the best bang for your money as you invest in that. With that, if there are any questions, happy to answer them, but I'll turn it over to Isaac to go forward. Yeah.
Thanks, and I'm excited to demo some of these capabilities in the next section. But before we just go into the demo, I want to kind of talk through the final integration points between Tecton and Sagemaker. So as Arnav mentioned, Sagemaker is going to be able to abstract a lot of the complexity of the ML side of your pipelines. Tecton is going to be able to abstract away the complexity of those data pipelines. And we see those combination of those two being the largest bottlenecks to getting these real-time applications into production. And we see that by combining these two services, your teams are able to focus more time on what you do best, which is applying your data domain and ML expertise to the use cases rather than managing infrastructure or managing or maintaining existing use cases. So let's dig into those integration points a little bit further, talking about inference, development, training, and as well as ML ops. So the first integration point is going to be around your inference engine. So this is a simplified diagram where we show how a front-end application would be able to call a fraud API. A fraud API would be able to invoke a Lambda, which will, one, make a request to Tecton, get features, and then provide those features to a SageMaker endpoint in order to make a prediction. There's ways to optimize this architecture further, but in this demo, we'll actually show that this simplified architecture is still able to get really good latency. It's able to scale up to a high amount of traffic, and you're able to support the freshness requirements associated with it. The one thing I want to emphasize as part of this inference pipeline is the reliability of it. Tecton and SageMaker are trusted by industry leaders for mission-critical workloads on these inference pipelines. The other integration point is around the development notebook. As Arnav mentioned, SageMaker Studio Lab is one of the best interfaces for model development. And Tecton integrates directly into this interface. So you can have a single interface where you're able to do development of both your feature code as well as your model code, connect to GitHub, connect to your CI/CD, as well as your MLOps pipelines, all in a single source of truth. This allows you to really speed up your iteration cycles and have kind of a single entryway for all of your jobs. Tecton is a declarative framework. So you can have your feature repo, again, in that Jupyter Lab environment. And Tecton is going to be able to manage those repos, declare them, and spin up the data pipelines that are going to materialize that data both into the online store for inference, as well as the offline store for training, again, all within that single Jupyter Lab environment. And then Tecton also integrates with your CI/CD pipelines and MLOps tooling. So this is, again, a simplified workflow that highlights how you might spin up a training pipeline. Here, you might first deploy your data code. We support ephemeral compute. So within a low compute environment, say your SageMaker Lab notebook, you can quickly spin up a job that's able to, say, be 25 workers, X large, to process terabytes of data and build out that training data set. That training data set can then be passed into a SageMaker pre-processing and training job. Hey, maybe you're jumping from CPUs on your training job and your data processing job, and then you're able to switch to an NVIDIA GPU for your model training, all within a centralized workflow. And I'm going to go into more detail on this, and we're going to step through these processes during the demo. The last thing I want to call out is just a couple Tecton specific components in common, just so you understand what Tecton does and what it doesn't do. The first thing I want to call out is that Tecton is not just a storage layer. Tecton includes an aggregation engine that is able to manage your future processing jobs. So we're able to take your raw stream sources, batch sources, API resources, and we're able to process those in a cost-efficient manner and store those into the feature store, both the online store for training or online store for inference and offline store for training in a very cost-efficient way while maintaining those ultra-low latency requirements. And our aggregation engine is what enables us to do that. The other thing I want to call out is that Tecton is also a serving layer. So Tecton has different components within our serving layer that enables us to, one, provide ultra low latency, but two, provide resilience and cost efficiency. So a couple of these components are, one, we support a in-memory cache, which is extremely useful for many use cases like recommendation systems. We're able to see improved latency and cost associated with that. Tecton has isolated environments, so you can have one fraud detection workload on a certain set of feature server groups and your personalization use case on another, and not have to worry about noisy neighbors or resource contention. Tecton also offers auto scaling, which is a great way to cost effectively manage your different traffic patterns. So from there, I want to make sure that we have some time to dig into the demo itself. So I'm going to pull out a presentation mode and switch over into the demo. So the first thing I'm going to do is within our Jupyter Sagemaker Studio Jupyter Lab environment, I'm going to pull up a notebook. And we're going to go through 3 notebooks here to mimic kind of the end-to-end development process that we kind of started with in the first slide. So one of the callouts for this demo architecture is this is very similar to the diagram I showed during the presentation. The major change here is that we've replaced the front-end application with a test notebook. So this test notebook is going to be what's making the calls to the fraud API, which is again making these invocations to both Sagemaker as well as Tecton. So let's kind of mimic let's start mimicking a attack vector. 2, say like we find through exploration, we're able to identify kind of a new pattern that we want to make sure that we're able to resolve. 2, we're going to walk through how we can discover existing features that might resolve that issue. 3, we're going to build some new features associated with that. And then 4, we're going to train a new model that's able to on those new features and then deploy that model in order to address that pattern. So let's go through those components. So first, I'm going to kick off a couple of helper scripts that's going to create some helper code. I'm going to warm up this Lambda. Then I'm going to kind of display this front-end interface. So this is, again, mimicking kind of what you would see in the application. And let's test out these different components. So let's first put in a, say, $300 transaction. Say we're trying to, and see what we get. So the first thing we see here is that this transaction was successful. We see the end-to-end latency for this real-time application is about 73 milliseconds, which is below kind of our 100 millisecond target for this. So we're looking good. Now let's go, instead of 300, we want to make a transfer that's, say, 3,000. We hit this submit, and we see that this time the transaction is denied. So what this is showing is that we are able to take some of these real-time information from the request itself and use that information in real time in order to make a better model prediction. We're so far so good in our fraud detection engine. But now let's say we have a new attack pattern that people are coming up with, very common, which is doing a large amount of small transactions in a short amount of time. And we see within this methodology, we're not able to capture this pattern. And this might be costing your team a lot of money before you're able to detect this pattern. So overall, we've identified that there's a gap, there's a new attack pattern, in that we want to make sure that we're able to take some of these near real-time events and include those in our model in order to kind of address this pattern. And during this analysis, we might also do some additional analysis and see that, hey, this also often occurs for recently created accounts. So we also have a hypothesis that we want to create another feature, which is the account age of each system. So let's go through the next process of how we would go ahead and build out that component. The first thing I would do would be around what I call discoverability. I'd want to go into the Tecton UI and look at the existing feature service that is powering this model. So within Tecton, we provide a data flow UI that's able to quickly visualize the different components of this data platform. At this point in time, I'm going to kind of touch on a couple of key terms that are native to Tecton. The first thing is a feature. This is going to be a single signal, such as account age, that is going to be an important data element for your model. The second is going to be a feature view. This is the functional unit of Tecton, and it is essentially a set of features that are organized and managed together, both in your online store as well as your offline store. We also have, of those feature views, there's different types. We support batch feature views, which is kind of on a daily, hourly cadence, real-time feature views, which are calculated at the time of request or at the time of inference, as well as stream feature views, which are able to meet some of those low latency freshness components, like, hey, I want to get this in less than a second, update the feature store in less than a second. And then the last piece is around this feature service. This is a abstraction layer for the serving side, and it notes the different features that would be returned for each request. So as we started with, we were looking for two major feature patterns. The first is a stream feature view that's able to calculate the total number of transactions, say within the last minute or last 5 minutes. So one of the things I can do is go to the Features tab, and I can see the different features that are available in this workspace. So I see that we have some features for different use cases, such as features around IP location insights. We have some embeddings that we've created off of user behavioral data. And we see at the bottom, we also have a stream feature view that is able to calculate those transaction velocities. I can click into this feature view, and I can again pull up the data flow for that feature view, which gives me the full lineage. I can see the data sources that are powering it, as well as the different features associated with them. I can even go into the transformations and see the logic that is powering each one of these feature views. I can move over to the metadata. I can also see some of the governance requirements. I can see the owner of this feature view. Here we see the owner is Mike. This might be our steward for our given domain. And I know that given that Mike's the owner, that I have a higher confidence that this has been validated and is a high quality feature. I can see who last updated that. It's Isaac. He's a pretty swell guy, does pretty good feature engineering. I trust his work. And we can also do things like add tags on this. This is really valuable for cost attribution. Any tag that you're putting on a feature view is actually passed down to all of your underlying AWS resources. So you can see the EC2, DynamoDB storage, and other storage costs, and other AWS costs associated with it. So you can attribute costs from, say, your fraud team to your personalization team. So overall, what I've seen here is a feature view where I can check the status, the monitoring of the component, and really gain confidence that I can use this feature in my feature view. I'd like to contrast this to if you didn't have this level of discoverability and governance. You might be searching your repo for different features that follow this pattern. You might look at a feature or a data dictionary if that exists might even just be slacking some folks to see if they've built similar features. Here we're able to see this all within kind of one framework. So now let's go ahead and take a step back and actually go through and incorporate this feature view into our new feature service, as well as build out a couple additional features that we know are going to be relevant. So I'm going to go ahead and then kick off some helper code. And just as a refresher, from a feature development standpoint, the basic steps are: one, you're going to define a feature view within a Python object. This is going to include a decorator, which controls kind of how this feature view is configured, as well as a transformation logic associated with it. Once that is applied, Tecton is going to spin up data pipelines. This can be on EMR, this can be Databricks, this can be Tecton's own Rift data pipelines. We give you the opportunity to use your own compute associated with this. And then we're going to be able to store that in the online and offline store. And again, all of the data, especially all the data at rest, is going to be on your owned and maintained AWS accounts. So any data at rest is not going to be in Tecton's component. So let's look at this as an example. Let's pull up the user transaction velocity and see an example of one of those feature views. Here, we're able to see our stream feature view decorator. We identify a source. But one of the things I just really want to emphasize is this aggregation engine. So oftentimes when you're building stream feature views, especially over different aggregates, the complexity is really high. You might have to kind of create a Spark SQL script or create some custom Flink jobs that are able to calculate these near real-time features. So like something like total transactions over the last minute. With Tecton, you can define all of that just with essentially one line of code, where we're saying, hey, we want to define a feature called total amount over the last 1 minute. We want to make sure that we're doing a sum. We want to use the amount column from our data source. And then we want to do that aggregation function over the last minute. And all of that is going to be defined in this very simplified abstract nature. Here, you're also able to define kind of those other key configuration components, like how far back you want to land this data in the offline store for training. You can look at the environment associated with it, as well as apply different metadata components on this. So now that we've kind of looked at this code, we can go back to our feature view notebook. And I'm going to kind of start sanity check. I want to spot check that this code is working as expected. So I'm going to log in to Tecton. One of the great things about Tecton here is that everything's going to be, from a permission standpoint, be scoped to your user and onto the session of this notebook. And I can do a quick spot check of this data. Here I'm using, I've kind of pulled in a very short 2 test cases, and I'm going to be validating some of those components. And so here we can kind of validate some of the data for this user transaction velocity. We see that good call out here. We're going to have some nans that we need to make sure that we handle in some of our post-processing, as well as we can see that, okay, we're getting data as expected for some of our historical data points. And so let's just talk through a couple takeaways here. One is we just showed you how you can easily reuse existing feature views. You do not need to create, one of the huge value propositions of a feature store is that reuse, and Tecton is able to do that. And more importantly, we give you the governance and metadata that gives you confidence in being the ability to reuse those features. And then the last thing is that we just showed our stream aggregation engine and how you can easily define stream feature views and have those spin up both your streaming and your batch data processing jobs to be able to efficiently land this data into the online store and make it available for low latency retrieval. So now that we have kind of created a stream feature view, let's create a couple more batch feature views locally and test out that development framework. So the first feature view we're going to want to create is a user profile feature view. This feature view is going to take data from our user source and is going to capture kind of basic profile information around this, such as the job, date of birth, last sign up timestamp, and the home location of that. So with Tecton, one of the values is that you can test everything locally. So I can hit, can define a feature view, user info locally, and then I can spot check this user info feature and test that everything is working as expected. Once I'm comfortable that everything is working as expected, I can then take some file, bring in some additional imports, and actually write this value into our feature repo. So feature engineering can be as simple as that, all within your Sagemaker lab environment. One of the most challenging, so batch examples are pretty simple, but from a compare and contrast. But one of the most challenging features for kind of build it your own environments is what I would call derived features. So derived features are features that take information from your real-time context and do comparisons with your either real-time stream feature view data or batch components. So this might be something like calculating account age, where you want to compare the request timestamp with a historical timestamp. You might want to create like a z-score, where you compare the amount of from the transaction with a historical mean and standard deviation. Or you might even just want to compare the ratio of transactions within the last 5 minutes with transactions in the last 30 days. So how can we build out those feature views? So Tecton has its own calculated feature framework that allows you to do this in a SQL-like environment. So this enables you to define these features not in Python, which means that under the hood, we can run these super, super fast. And then we can also kind of abstract the complexity of running Python on these training jobs and get really good offline retrieval as well. So we look at how would we be able to calculate these derived features. Here we see that SQL-like language for a date diff. Here we're counting an account age in days. We're able to calculate kind of using our date diff function. We define how we're doing that date diff, and then we just enter the 2 timestamps that we want to include. The first is coming from that batch feature view we just defined in the previous step, which is the last sign up timestamp. And the third is going to be that request timestamp. So this is coming from the request itself. Additionally, we can do kind of that ratio that compares the last 5 minutes with the last 30 days. Again, we can do using a very simple framework or a SQL-like expression. And then we can also do more advanced use cases like a z-score. Once again, we're able to kind of test these and make sure that everything is working locally before we kind of write these into our feature repo. So now that we've kind of created our batch and real-time feature views, take a pause, show the simplicity of creating some of these production-grade data pipelines. You don't need to be an expert in SQL, an expert in PySpark, an expert in Flink in order to define some of these very complex feature patterns like a z-score or a real-time feature view. The other thing I wanted to kind of pause here is that we're able to show that we're able to quickly iterate. We're able to take logic, define that locally, and test out the output. What's not shown here is that you also can do a lot of unit testing and define those unit tests in this notebook environment as well. So the last step for the feature development lifecycle is to update the feature service. So here I want to update my feature service with 2 of the feature views that we just discussed during this demo. The first is going to be that user transaction velocity. This is that stream feature view that we created, as well as we're going to add that derived features. Once again, we can kind of follow a similar framework. We're able to execute these and spot check this locally. And we're able to see kind of that those results. We see that our code is working as expected. So once again, I'm going to go write this file into our feature repo. So what's next? So once we've developed that feature repo, in most organizations and most teams, this is where your CI/CD frameworks are going to shine. So in the vast majority of cases, you're going to integrate Tecton into your CI/CD pipeline, like a GitHub Actions workflow, and you're going to push this this change into your say a staging branch, and that staging branch is going to, or in that GitHub Actions workflow, is going to apply some of this logic, which is going to execute some of these data pipelines, et cetera. For the purposes of this demo, I want to kind of take a peek behind the scenes. So I'm going to show you how a lot of this can work manually, just so you get a better understanding of how Tecton integrates with some of these CI/CD pipelines. So with that, I'm going to move into my terminal, and I'm going to run a Tecton plan. So the Tecton plan is going to analyze the new components. It looks like I've been logged out, so I'm going to log in here. Great. Now I can run a Tecton plan. And this is going to show me all of what's actually going to be applying to our workspace. And it's great because it also shows me the different data pipeline jobs that are going to be kicked off. So I can see that we're creating 10 backfill jobs that are going to be writing to the offline store, as well as on an ongoing basis, I'm going to be creating a daily batch job that's going to write both to the offline and online store. So once I've kind of have confidence in the objects that are being run, I can run. It's also, you can go to the web UI. That was a poor click, but also shows that capability. I can also do a Tecton apply. And what this is going to do is actually apply this to our Tecton cluster. Hit yes. And if we pull up our environment here and we go into kind of hit refresh, we can see that we've now created kind of this batch user information profile. And if I go to my feature services, I can click on it and see that new feature service that we created. And I can see the full lineage associated with that use case, with the user transaction velocity added, as well as those derived feature views added as well. Also, you can also check kind of the materialization jobs of those and see that we need to wait for some of that user profile in order to be in, before we can be fully ready. Awesome. So from here, just to pause, what we've shown is how to kind of do the end-to-end feature development lifecycle. We've taken our hypothesis of what features are going to be valuable. We've defined that code locally, tested, making sure everything's working as expected. And then we've applied these new feature patterns into our Tecton cluster. This is going to be spinning up real materialization jobs, which are going to land that data into the online store and make it an offline store, and make it available to our model service. So now let's jump over to our third tab, which is going to talk through how we can integrate the feature components into the model components. So the MLOps pipeline here is oftentimes very complex. And so the purposes of this demo, I'm going to be focusing only on a subset of the steps for this kind of overall MLOps workflow defined. But at the end of the day, what we need to do is, one, after we've applied this code, we need to kick off a training data generation job, which is going to retrieve data from the offline store, do some point-in-time joins to make sure that we're getting a training data set that has no online and offline skew. We're then going to pre-process that, train a model on it. We want to evaluate that model with some of the back-tested data that we just provided. We're then going to register that model and then deploy it to our Sagemaker endpoint. So again, normally you're going to be leveraging something like Sagemaker pipelines, MLflow, or other tools in order to orchestrate these pipelines. But we're going to go, for this demo, we're going to go through this manually just to show how everything's working underneath the hood. So the first thing we're going to do is retrieve a labeled data set from our environment. We are then going to kick off a training job, a feature generation job, which is going to retrieve data from the offline store. For this component, I'm just using our local method. So this is using our Sagemaker Studio Lab notebook in order to retrieve the data. But Tecton also offers a remote data set generation, which you can create some ephemeral compute clusters to find the instance type for those, which is often very useful for large offline retrieval jobs. Say if you need to retrieve $100 billion training, 100 billion row training set. Now that we have created our training data set, we're able to pre-process the data. And we're able to then pull in a XGBoost model from AWS, and we can train our model off of that pre-processed data. So as this is occurring, we've kind of spin up a ephemeral job. This is not tied to the Jupyter notebook. And so this gives you a lot of flexibility to create a very beefy cluster as part of your training job, or switch to something like a GPU that you know might be much better for model training. Say you're using a PyTorch or Tensor or other type of model. While this waits for it to run, I want to take a circle back to that offline retrieval job we just ran to kind of talk through a little bit more around how Tecton has handled this behind the scenes. What Tecton is doing is taking your labeled data set and doing point-in-time joins on the offline store in order to retrieve data as it would have been at the time of inference. So Tecton has a lot of work underneath the hood to minimize training serving skew. So one of the common gotchas you see when you're building out training data sets is that you might introduce leakage either because the inference pipelines are different from your offline pipelines. You might be doing your point-in-time joins at the time of the event instead of at when that event was actually materialized into the inference, or you might not be accounting for late arriving data in your system. So Tecton in its offline retrieval methods are able to mitigate for all three of those kind of common gotchas when you're creating training data set, and we're able to create some very high quality training data that you can use for your model, as well as to kind of back test. So you can do this as part of your development cycle. You don't have to deploy this code into your inference, wait a month for the real traffic to come in before you actually are able to kind of use that model. So here we see that the model is still in process. So I'm going to step through a couple of the other steps here. The next step we're going to do is going to create a SageMaker model using kind of our SageMaker lab methods. We're going to then create a transform job that we're going to use for back testing. We're going to then back test that and compute the performance metrics. And you can kind of read out those performance metrics here. Finally, we would want to then register that model before we then update that model into our component. So let's go through kind of those steps here. Now that our training job has component, I see that our, so we can step through this, create the model. I'm going to jump a couple steps for time purposes and go straight to the update. I'm going to update on this new model. As we see, something is not working as expected. Oh, my model group has failed. The demo gods are not in my favor here, our live demo gods. So what I'm going to do is quickly pivot. So as part of this, prior to this component, I've deployed this already into our production environment and shadow environment. So I'm just going to talk through a couple of these components here. So we'll go to this last component. So what I've done here is I've created a endpoint config that has both a production variant that's pulling all traffic, as well as another production variant that's deploying shadow. So prior to this demo, I ran this workflow kind of end to end, and I was able to produce that value into this shadow environment. So we can go back to our initial component, and let's test out that new model that we've kind of deployed previously in this environment. So I'm going to go to my updated architecture. Once again, I'm going to warm up the Lambda and set up some of the helper code. I want to take a pause here and just say that we've slightly updated our architecture here. Essentially what we've done is added an additional Lambda that's going to be taking each one of our requests, and we're going to be streaming and ingesting that value into Tecton as part of this architecture as well. So now we can look at the updated kind of form. This is again hitting the shadow variant of our endpoint. And let's look at the same exact attack vector that we talked about previously. Let's hope that the live demo gods are a little bit more in our favor here. We can kind of run through these components, and we see within a very short amount of time, the model is able to take in some of those real-time features, and it's able to make a new prediction and denying this within a very short amount of time. So we're able to, we know that we were successful, and we were able to incorporate and integrate that new stream feature view and other feature patterns in order to address that attack vector. So I'll pause here just to kind of close out on a couple of the takeaways from this demo. The first thing that we showed here is that we had ultra low latency real-time inference. As we can see here, we're able to deny these in well under 100 milliseconds. Here we're able to incorporate both real-time, near real-time, and batch feature freshness. We're able to abstract the complexity away of building enterprise-grade data pipelines. We're able to build out a point-in-time accurate offline data set or training data set, and we were able to backtest that on the new features that we developed. And then we were able to deploy that new model into production and kind of test that component. And at the end of the day here, what Tecton and Sagemaker do is simplify the complexities of building and deploying ML and AI infrastructure, both the ML side as well as the data side, allowing your teams to do what they do best, which is build new use cases. So with that, we come to the end of the demo, and I will open up the floor for questions.
Nice job, Isaac. Can you hear me?
All right.
Yeah.
Okay,
perfect.
So just going through the Q&A right now. And I guess, Arnav, I know you've been off for a while. Any questions that you want to jump on right away?
Yeah. I want to address one very good question asked by Selvam. He asked, when would you recommend choosing between SageMaker Notebook versus EMR Notebook? So it's going to be a little bit of a long, drawn-out answer, and it's only because when we first started on building notebooks, AI and data and etc. were very fragmented. And so we heard from our customers that were running, Spark jobs using EMR that it would be great to have some kind of IDE that can help them monitor the clusters and quickly make changes. And that's what led to the genesis of the EMR notebook. But as time evolved and we noticed that, data engineers, ML engineers, etc., they're working in lockstep for building models and tuning models and building features as we saw today. We started augmenting integrations with our native services like EMR and Glue, etc., through the SageMaker Unified Studio IDE. So the short answer is, if you are starting today, I would recommend to start with SageMaker Studio Unified IDE because it has all the built-in integrations to all the data services that we offer. So that would be my recommendation if you're starting today.
Yeah, I can touch on my perspective on that too. Tecton supports kind of integration with both Sagemaker notebooks and EMR notebooks, but we've seen our customers and other folks being much more successful leveraging Sagemaker notebooks for that end-to-end development lifecycle. Another question we got from Anshul was around feature computation. Is the EMR cluster managed by Tecton? Under our shared responsibility model, the EMR cluster is going to be under the data plane or in the customer's account. Tecton is going to be responsible for orchestrating and configuring those jobs. So we offer a very easy kind of configuration environment where you're able to define different parameters like the instance type, the number of nodes, the different Spark configurations, and we push that into EMR to run that logic. Looking through this, does Tecton have SSO integration with Okta? The answer to that is yes. One of the questions was around the partial aggregations stored in Feature Store and whether further aggregation is needed at serving. That's a really good question I want to kind of touch on in Tecton's aggregation engine. So Tecton offers multiple levers to balance cost efficiency with low latency serving. So Tecton leverages via our partial aggregations. We do kind of store those partial aggregations into the online store. Then at the time of request, we are going to retrieve those partial aggregations and do kind of that final aggregation and make that available to the model service. The rationale around that is around flexibility and cost efficiency. This enables us to have many different time windows on that same aggregation. So within that stream feature view that we kind of looked at, we had aggregations over a 5-minute, 1-minute, 24-hour time frame. And that partial aggregation framework allows you to have that flexibility associated with that. In order to enhance the latency for these partial aggregations, Tecton has often also enabled a compaction framework, essentially taking more of a lambda data architecture approach, where on a batch or regular basis, Tecton is able to compact many of those partial aggregations into a single record, which is going to make it very low latency. You're going to retrieve less data from your online store for each request. And that's what enables us to meet some of those ultra low latency use cases. Another question we got was whether the joins or other components are written SQL as a transformation code. Tecton offers multiple transformation modes for our compute engine. You can find your transformation logic in SQL, you can in Python, in Pandas, in Spark SQL, in Snowflake SQL. So we offer a lot of flexibility in how you do that transformation, and it really depends on your data source. So if, say one of your data sources is Snowflake, you can leverage our Snowflake SQL transformation node, which is going to push down a lot of the compute to Snowflake in order to do those joins in a very fast and cost-efficient way. And then Tecton is going to do kind of some of the final aggregations and write that into the online store. So we also a lot of flexibility in that transformation engine. And yes, the clarification is that data prep component would be expected to do in that transformation logic. Arnav, any other ones that you see that you wanted to call out specifically?
There was one that I can't seem to find, but there was something about security. I don't know if we already answered that in chat. I can't seem to find it. But do you want to just touch upon security? That would be good.
Yeah, I think that's a really good call out. So Tecton underneath the hood is passing kind of all of your basic certifications, so like SOC 2 and other components. We also take kind of a hybrid data architecture that allows you to kind of make sure that all data is under your data plane and is encrypted at rest, and anything that's in transit is also going to be encrypted. Tecton also offers a lot of RBAC and other methodologies to make sure your cluster and your data are going to be secure. We integrate with SSO to make sure, as well as other providers, in order to make sure that only people who should have access to data into these pipelines do have access. So there's a lot of things underneath the hood. I'd recommend going to our docs page where we outline in more detail our security model. I guess one other question I see called out here was around the interesting choice for Amazon Lambda. How does this architecture manage low cost at large scale? I think that's a great question. I chose Lambda for like my invoke endpoint, really for simplicity of this demo use case. There are different other options. Like if you're trying to optimize for a huge scale and ultra low latency, I've seen a lot more people. I look at technologies like gRPC as well as more persistent compute, such as either a autoscaling group with EC2 or a K8s cluster for that invoke endpoint component. That said, Lambda does scale to a pretty large extent, especially when you have that provisioned
throughput. Yeah.
Thanks. I need the Amazon expert to get my
Yeah,
here.
I can chime into that. So, of course, Lambda can, it's a very interesting point, but we recommend Lambda specifically if you have spike key traffic, right? So, but if you see that cost is becoming an issue, then we recommend our customers to move on to more persistent options like what Isaac talked about. But before that, I mean, if cost is a factor, we are ready to work with you and maybe do some kind of private pricing agreement with the service team and based on the volume that you're bringing in. So there's multiple options. Yeah, because the moment you add a persistent cluster in the mix, then there's some amount of work that will be needed to operationalize it and manage it and stuff. So it really comes down to, pros and cons when you determine that choice. Yeah.
Great. I think we have time for one more question. I think we have a question around feature stored in Databricks in Snowflake and whether it can be used in Tecton or must migrate into it. The short answer to that is you would need to migrate that data into Tecton. Tecton offers capabilities such as feature tables, which allow for the very fast migration of pre-computed features into Tecton. And we offer multiple migration strategies, whether that is just directly copying those pre-computed features into Tecton, more of a lift and shift approach or a modernization approach. And you can work with kind of our Tecton team in order to find the best migration path and best strategy that meets your requirements in a cost-efficient way.
All right, perfect.
Great. Well, we really appreciate the great engagement and great questions here, and appreciate everyone's time. Thanks.
Thank you. Thank you, Isaac, for having me. Bye.